Welcome to the interview series from the ImAgE-D Doctoral Network. And today we have Gaétan with us from the University of Bielefeld. And I know that it's been a while since your last interview, so how have you been since then?
It's been great. I've been doing some progress. Life is comfortable in Bielefeld. So.
Okay. How was your typical day as a doctoral candidate in Bielefeld?
My typical day. So I don't know. I'm not very supervised in my work. I do most of my work by myself. So I just go to work kind of like whenever I want. Usually it's around 9 or 10 a.m. I typically have my list of things to do for the day. Like I keep a list of like a to-do list of like what I have to do in the next few months, right? And I try to see what's relevant to do at the current time. So I come to work, unless I was doing something the previous day that I have to finish, I just look at that list and I
just do the checklist, right?
Yeah, like
but I like that because I'm not also
like,
not a very morning person.
Because in the things that I do, sometimes I need to order some parts. They can take really long time to come, so I need to find ideas of what to do in advance to have it ready. So that's why I keep a list, so I don't forget what I have to do.
Ordering stuff is something that we all have to deal with, and it's not so simple, I must say, and it changes from country to country, and we have different procedures. But let's forget about that, I would say.
And then and then when I feel good about what I did for the day, I just usually go to the gym, go do my groceries, and go home.
Okay, it's very relaxing evening, I would say, right? Don't carry the work to home, I would say.
Yes.
Yeah, that's good. So would you like to share with me what is your project actually about?
So my project right now, so I'm working on this SIM, structured illumination microscopy. So it's a microscope that you guys use in biology to look at those little fenestration in the cells, right?
Yeah.
And so these microscopes are quite expensive and require a lot of engineering. But at the University of Bielefeld, we're working on like smaller versions of them, more usable, cost efficient, also that you can ship easily.
Homemade device, I would say.
Yeah, homemade device for science, right? To avoid paying hundreds of thousands. Or even, I don't know exactly how much these cost, but they're really expensive.
Yeah, true that.
And so it's homemade device, and I'm working on it's like an iterative process. It's like people before me worked on that. They made their own version, and now I'm working on my version that is like a bit lighter, easier to operate. It's like sort of like self-aligning, like using software and controlling mirrors with software. We can have a bit less need for expertise to run the setup, because those are also usually need an expert to operate and maintain. Not the commercial ones, because they're very expensive and like probably self-aligning as well, but the homemade one definitely need an expert typically to operate over a long time, because you need to realign them, maybe maintain them.
Yeah, I mean, like, I don't have an engineering background, so I believe whatever you say. But anyway, you are building up this SIM, and but however, are you dealing with any of biological stuff?
Like, so far I am not.
So far not. Okay.
So the goal of these microscopes is they're developed for biology.
Yeah.
So far I have not interacted with much samples apart from testing. Because I'm a year and a half in my PhD. I had a setup previously that I shipped in Poland to the Krakow team.
Yeah.
They use it for samples, so I use it for samples there, but I'm not exactly sure what I'm looking at. I know we're looking for fenestration. I'm not exactly sure.
So you always need the biologist anyway there to combine the technology with the application, right?
I wouldn't be able to provide the samples. I don't know what to look at. That's not. I don't know much yet about it.
Yeah. So at this point, like, do you think like you would need to take any courses to learn more about this biology that could support in this research that you are doing?
Yeah,
or you would like to focus just like, in the building, in just the engineering part?
I'm not so interested in the biology, but my guess is that once I got this setup working, which is almost ready, by the way, it's probably going to be doing the first images in the next week or two.
That's really great, I would say.
Yeah. Well, eventually this setup is meant to be to travel with me to other groups of the consortium and do some imaging for those groups. So I will probably have my fair share of interaction with biology at this time. I don't think I would necessarily take courses per se, but like when I was in Krakow, Bartek did like sort of like a crash course on AFM for me, right? To learn about AFM. And I think in the same way, when I would go to these labs, they would tell me about.
You can learn on spot.
Yeah, they would teach me what they do, why it's relevant, what they want to see, and why they want to see it. But I'm not so interested in taking courses for biology.
Okay, I understand and I respect that. So I believe you are like halfway through your PhD, so you still have a long way to go. So, but anyway, you have achieved in building this part of the sim, right? Like, but so you would like to share any results that you are actually proud of, or that you just want to share with any achievements?
There is some results that I was proud of. I don't know if it's easy to explain in an interview, but
short and sweet is fine.
It's basically when everything clicked. So like I have those little mirrors, right, that I control mechanically, and then, but they're a bit hard to drive. Like they go through probably 8 lenses and all sorts of optics, but you want to position them very, very precisely to steer laser beams. And so then for that I use a camera. So by using this camera and some live image detection software and the whole calibration loop and feedback loop, the moment where I was quite happy about my result is that I run my calibration sequence, and then I have my beams, laser beams, exactly in real time, placed wherever I want.
Where it was supposed to be, right?
Doing the patterns. It's sort of what I showed in my presentation. Like I have my beams, they're like symmetrical and move exactly like what I want, which means they will. If they are symmetrical and centered where I want, it means they will generate the proper patterns I want in the sample for the image. So it was at the end of last year. I was really happy about it because it's like the moment where everything comes together. But there will be another moment where everything comes together, which is when I actually take an image, right? Because now it's like I know all the theories working. My patterns is there.
Yeah.
And then the next step is have these patterns as a sample and reconstruct image with all that. It's like you trust the process, and in the end everything
then
works.
From the theory you have to move to the practical. And with this, like actually you anticipated our last question, which actually is about future and your next plans. So, but you can tell me more about your milestones that you have set.
Well, my plan is to finish this, and I'm scheduled to go to Tromsø. In Norway, to the lab of I think it's Peter McCourt. Right. I'm scheduled to go there. That would be the first place I go when the setup is working and functioning. There's also Manisha, DC from here, from the INL in Braga. She will come next week to Bielefeld to learn about SIM.
Okay, that's really nice.
So she probably talked about that. So I will help her build her structured illumination setup, homemade setup as well, which is on the same plan as the one that was that I built for
in Krakow, right?
In Krakow, yes.
Yeah, that's
so it's a similar plan. So I will help her with that, and at the same time I can share with her my setup and how it works.
Yeah, this really sounds really very interesting, and it shows how actually the network, the ImAgE-D network is working because you build something in one country, in Bielefeld, and then from one city to another you are actually bring the instrumentation so that also your other colleagues from the network can use it. And I think that is really a great achievement, and I wish you all the best for your future success, I would say.
Thank you.
Thank you for being with us today. Thank you.
Thank you.